as someone who's a manufacturer in the private sector, what I tend to look at trends. And the trend that we're seeing really around the world, not just in the U.S., but all over the world. In fact, I'd argue that certain parts of the world, it's even being accelerated much more than we're seeing here, is that there is an acceleration towards having systems, whether they are political systems or economic systems or living systems, more and more brought together into a highly centralized pocket. And whether you're talking about political systems or engineering systems, or whether you're talking about just everyday life, the problem with a highly centralized system, regardless of what kind of a system you're talking about, is that A, it tends to become less efficient. B, when something breaks down, it affects the system as a whole. That's just, it's almost axiomatic that one has to look at that, and there's not much you can do to deny it. It's just this overwhelming proof that this happens. So the fact that what I see as an individual, larger attempts by both, when I say that the utility system, by the way, they're so monopolized, and they have such a large amount of privileges from the government. They're really part of the government. And so when you see that, what happens is that now services are not just simply derived from a highly centralized and drawing a blank on a word here, forgive me, exposed system, if you will. But things also start to become a little politicized as to who gets what and when can they get it. So you don't really have an efficient way for people to, some people just need more energy than others. Some companies need more energy than others. Some entities such as hospitals and perhaps military stations, for example, they have a higher need than others, or whether it's actual or not, their perception is they have a higher need. And so by using backup systems now, it's a way to address that, which means if we continue to go in the same direction we're going versus, say, decentralizing something. Because in a decentralized system, you're still going to have problems. You're going to have some resiliency issues. You're going to have reliability issues. But at least when it happens, it'll happen in such a way that is to not impact everybody in the system. So to give you a good example how that might work, we're working with several different potential customers right now. But if you take a look at, say, someone who's building a home project of 40 homes, and they decide rather than tie into the grid, we don't need to get into reasons why they would or wouldn't, but let's assume that they just decide that that's where they want to go. They're not going to tie into the grid, and they're going to have their own energy solution that is, let's say, for all practical purposes, belongs to the project. It's their energy. So they become their own, if you will, they become their own grid. Typically, these microgrids, as we call them, they tend to be independent or quasi-independent from the main grid. When I say quasi-independent, the grid may come back, for example, and interact with us in a positive way. So, for example, there are grid companies right now, utility companies, that are now putting out feelers for people, say, like some of our customers who have their own systems. And then they have a large, anywhere from a medium to a very large amount of backup storage capability. Well, most grids don't have any capability of storing energy. When they make it, it either gets used or it's dissipated in heat or voltage loss, which comes across as heat dissipation. So if the grids could find enough people who are independent and have large energy storage, what they're doing now is they're offering them cross agreements where they'll be able to store that energy until they need it, pull it off the grid, and then be able to use it more efficiently. So when you have, however, in a non-centralized system, let's assume that those systems had even decentralized parts. So for example, if we had a system that needed 100,000 watts in order to be able to provide enough energy for 40 homes, if that was the number, rather than put that into one station, we would typically even decentralize even more by having, say, anywhere from 5 to 10 versus stations, each of which are connected. But if one goes down, the other stations can still stay up while you're repairing the one station that's down. So it may impact somewhat if you had like the majority of these things break down for some reason, say like in an EMP event and you didn't have proper EMP protection. But still, it's still going to be better than if you have one system that goes down and drags everybody else with it. Or worse, you have a section of the grid goes down. And then the result of that is that the rest of the grids that are operating now have to take up the slack, and where they risk being going down. Because again, there hasn't been much repair work done to our systems in the last 100 years. Those systems that were originally put together, many of them still have the original wiring under the ground. And copper and aluminum, those types of wirings, they just corrode after a while. They become worth less. And if you don't keep them up, they're going to become very problematic.